Today we're in section 4.5, which is using congruent triangles. We've done a lot with proving two triangles congruent, and we've learned several reasons to help us to do that. And today we're going to be still doing that, but then we're going to be using that to help us to find other pieces of information. So we're going to start off right away with a proof, because you know what better way to start than with a proof. Sounds great.
Excellent idea.
Okay, so for this first proof, we're going to be proving two triangles congruent. This is basically just a recap of what we've been doing. Okay. We currently know, and I given information, that segment RS is congruent to segment SU, and we know that segment RT is congruent to segment TU. Right?
Okay.
So we already know what?
We know two pairs of congruent sides.
So I'm going to mark that RS and SU are congruent, and RT and TU are congruent.
Which that's nice, because if you already have two sets, that means we need only one more congruent piece, right?
Absolutely. And if you take a look at that picture, what do you notice about that picture?
Well, I see that the two triangles share a common side, which means we can say ST is congruent to ST because of that reflexive property.
And once we have those three congruent statements, what does that tell us?
Well, I know then the two triangles are congruent, so I can go ahead and end my proof and say triangle RST is congruent to triangle UST. And my reason would be side, side, side.
All right. Easy enough proof, right? We've done lots of these, but just to give you guys that refresher of, we're still going to be doing this today. But today, we're going to be kind of continuing and not just stopping there at two triangles congruent. Okay. So what does it mean when triangles are congruent?
Okay, well, I'm thinking back to when we first talked about just congruent figures. Congruent figures meant all its corresponding sides and its corresponding angles are congruent. So all the corresponding sides and angles are congruent. So in this case, I proved the triangles are congruent with the shortcut, the theorem, or postulate, because of the fact that I had three congruent pairs of sides. But technically, because we know that their triangles are congruent, we know
other pieces,
more, right?
Because what else do we know? Now that we know that these triangles are congruent, what else do we know? We already have said that all the sides were congruent, but what else do we know?
Well, I also know all the corresponding angles are congruent. So, for example, angle R will be congruent to angle U. And then angle RST is going to be congruent to angle UST. And then angle RTS is congruent to angle STU.
So if in our proof we were then asked to prove not really that the triangles were congruent, but if instead we said prove that angle R is congruent to angle U. Once I know those triangles are congruent, what do I really know then?
Well, I know all of their parts are congruent. So I could technically say angle R is congruent to angle U, right?
We can. And there's a reason that we're going to be using to help us with that.
And we just don't know it yet.
We just don't know it yet. But this is where we're going today. We're still going to be given enough information to prove two triangles congruent. But we're not going to stop there. We're going to then use that, hence the name, using congruent triangles.
So
we're going to use that information to tell us more about that picture.
So technically, we're going to end up proving still congruent triangles like we've been doing for the last several days.
There's just going to be another step or two or whatever afterwards.
Okay, so what would be, the question really is what's the reason for that? All right, so tell me again, remember what we said. We said once the triangles are congruent, we know
all the corresponding sides and angles are congruent.
Okay, so I'm going to show you something on the next slide, and I want you to notice basically what we just said. It says once you know congruent triangles, we can conclude their corresponding parts are congruent. Now, what do I mean by parts?
Yeah, I remember we used that word. We talked about parts. We're talking about all the angles and all the sides.
And that's what when the last slide we talked about corresponding angles and corresponding sides are congruent. So here in the statement right here, I want you to read that. It says corresponding parts of congruent triangles are congruent.
Right. Well, that makes sense. That's what we just talked about. Sure.
So if we have congruent triangles, then all its corresponding parts are congruent. Now, notice the first letter of each of them are kind of in a different color.
Yes.
If I use this as a reason, which we're going to use an acronym for it. Make it
CPCTC.
This is going to be a popular reason for when. When are we going to use CPCTC? It's kind of a mouthful.
It is. We're going to use it anytime we already know triangles are congruent and we want to talk about other pieces, other parts of those triangles.
Okay, so
also
we know congruent triangles first, and then we'll use it to prove its parts.
Okay. Yeah, CPCTC, guys. You're going to hear this a lot. CPCTC.
So on this last slide, if I had proven the triangles are congruent, which we had no issue with that, we can then say any of its corresponding other parts are congruent. So saying angle R is congruent to angle U, we could say the reason is
CPCTC.
And again, the key here is you have to prove congruent triangles before you can prove its parts. And a lot of times I see students that will kind of forget that step. This reason is to prove its parts are congruent. It doesn't prove congruent triangles. It proves the fact that you know the congruent triangles, then you know its parts are congruent.
Yeah, you definitely already have to have the triangles marked as congruent before you can use CPCTC. Okay, so then let's try this. Let's apply this. We are going to be doing some proofs today just to get some practice with using this as a reason. And I'm going to go ahead and mark on the picture what we already know. We know that HJ is parallel to LK. So I'm going to go ahead and mark that as parallel. And we know that JK is parallel to HL. So looking at this picture, we've got two sets of parallel lines. And when I think about parallel lines, I often think about looking for special angle pairs. We're trying to prove that HJ, the segment here, is congruent to KL, yeah, to KL. We want to prove that they're congruent. We know that they're parallel, we just don't know that they're congruent yet. Okay? Now, if you notice, they are parts of what?
Two triangles.
Two triangles. So sometimes when we're looking at proving just certain parts congruent, we might want to think about the triangles first. And I'll tell you guys, here's the hint. Today's focus is on using CPCTC.
Yeah.
So kind of expect to use that one in almost every proof you're going to be seeing, or I should say every.
And it's pretty, and you'll see that a lot more frequently now. The stuff from the last two sections are going to still be applied because you still have to prove congruent triangles before you can use CPCTC. Exactly. So just keep that in the back of your mind.
Okay. What do you want to talk about first?
Okay. Well, if our goal is to prove HJ is congruent to KL, those segments, I have to first prove the congruent triangles. And based on the picture, I do see two triangles. But I don't have anything labeled congruent on them at all.
Right. So we know we're going to need three congruent
segments. Okay, so one thing you made a comment about was in the given, you were given two sets of parallel. And each parallel set proves probably something about the angle. So I'm going to start with the first set.
So let's emphasize those.
Segment HJ and segment LK are parallel. And there's your transversal. All right. There's obviously other transversal, but that's the one we're going to use because of the fact that you're trying to prove stuff about those triangles. So I'm going to say in this step, angle HJL is congruent to angle KLJ.
Okay, so you're saying this angle right here is congruent to this angle right here. And what's the reason?
AIAT.
Right. They're alternate interior angles. So using that alternate interior angle theorem, knowing we're going from the transversal to the parallel each time, we're marking those congruent triangles. Awesome. Okay, so we've used this parallel statement. We have another parallel statement too, though, don't we?
Yeah, since I'm giving you, or they're also giving you segment JK is parallel to segment HL, and I'm going to use the same transversal. I have some more alternate interior angles that are congruent. So angle HLJ and angle KJL. And the reason is also alternate interior angle theorem, which we could probably combine. Actually, we can combine those steps. But
so I'll go ahead and even just take off the 3 because we know it's still part of that second step. Awesome. Now, I'm going to go ahead and get rid of all these extra lines because not the whole picture, though. That would not be helpful. And we want to go ahead and take a look at, there's got to be one more thing. we've used all of our given information.
Yeah.
But we know we need 3 congruent statements. Right now, we already have 2 angles. Now, let me ask you this first. Would it be helpful to find the third angle?
No, because there's no such theorem or postulate that does that.
Right. So 3 angles by themselves does us no good. So we're not even going to be concerned about those other angles.
So we need a
But
side.
is there a side?
Okay, and it can't obviously be the side that we're trying to prove congruent, because then that defeats the whole purpose.
We don't know that yet. Exactly.
Yeah. So, but I do notice, and hopefully you guys see this too, the 2 triangles share a side. So I can say segment LJ is congruent to segment LJ because of reflexive.
Now, is this enough to prove the triangles are congruent?
Yeah, there's 2 angles and a side, and the included angle, or included side, sorry. So I can go ahead and say the triangles are congruent. Now, this is where in the last couple sections, they gave you what the triangle should be. So
yeah, that's what we're trying to prove.
How we name it.
Okay.
So triangle, let's say HLJ.
Oh, I started backwards. HLJ
is congruent to triangle KJL.
And I started to write HJL. There are other ways you could
yeah.
definitely write these 2 congruent statements as long as all of those corresponding parts are in that same order. So where I've got H, K should be in the same location of that congruent statement. So really watch those statements because, yeah, that's not what you're given anymore. Okay, and that reason was because of what?
Angle, side, angle, because the side is included between the 2 angles.
Okay. Now I've said that the triangles are congruent, so that allows me to now say that all
of its corresponding parts are congruent.
Absolutely.
And I notice segment HJ and segment KL are corresponding sides of the 2 congruent triangles, which means they're congruent. So I can say segment HJ is congruent to segment KL. My reason will be CPCTC.
Absolutely. All those corresponding parts of congruent triangles are congruent.
So again, notice all of this stuff is stuff we've been doing.
Yep.
And usually, and this is just kind of a pretty typical thing, once you've proven congruent triangles, CPCTC will typically follow because of the fact that once you know congruent triangles, then you know its parts. So just kind of keep that in the back of your mind when you're doing some of these. All right, so this next one, I'm going to start writing down the given.
Okay. And I'm looking, we have a set of parallels, but the segments that are parallel are also congruent. So we're looking at some information about those 2 segments. And as I look at them, I see actually several things that I can say about these from this point. And I remember we had a proof like this in one of our classwork assignments, and I noticed that there were several approaches to this assignment, or to this problem in the assignment. And there's not one wrong way to do it. Well, there's probably wrong ways to do it if you don't do the right,
there's not
use the right
one
information.
way to do
there's
it.
not only one way to do it. I see actually lots of angles, all the angles that could be congruent. Because knowing those lines are parallel, if I use RS as my transversal, I know that I have some alternate interior angles that I could mark congruent. So I could say angle MSA, and I'm just going to call it angle S for right now because that's the only angle coming off of it, is congruent to angle R, and that's because of the alternate interior angle theorem. And actually going along the lines of the alternate interior angle theorem, I could also talk about MT being our transversal. And with MT being the transversal, I could talk about how angle M was congruent to angle T, still based off of that alternate interior angle theorem. But I also look at that and I realize that I also could have talked about the vertical angles, the vertical angles that exist there. So I could have talked about angle MAS being congruent to angle RAT.
Okay.
And so really, you pick 2. We're at Panera right now. You pick 2. It doesn't matter which 2 angles you choose. As long as you've got 2, and whatever your reason the triangles are congruent supports the angles that you have marked.
And the reason why you only need to have 2, because you already have one set of congruent stuff. So you just need 2 more things.
And we know that we couldn't use all 3 angles as a reason by itself either. So, again, you pick 2.
Yeah. And the thing, I like what you did, because if I use vertical angle theorem, which is not wrong, it just adds another step.
Right. That's true.
It's just, but we'll always, when you have a set of parallel lines or segments, will you always end up with two pairs of alternate interior angles congruent?
No, not necessarily.
In this case, it does because of the fact of how that picture is.
And there's two transversals coming from there. Yeah.
So, okay, now, one thing to keep in mind, though, on this problem, Ms. Hograve is kind of jumping right in because she kind of knows where she's going here, but don't forget where you're going. Notice the prove part doesn't say anything about proving congruent triangles.
Right.
Right? But the giveaway is that's been our focus. Notice we do have two triangles, so that's kind of the obvious and she's feeding off that given. This given told us this. All right? This given told you the step 2. So that makes sense. Think about where you're going here. You're trying to prove A is the midpoint of segment MT.
So I really want to prove that MA is congruent to AT to be able to talk about, well, if those two segments are congruent, that A must be the midpoint because it's forming those two congruent segments.
So if we're trying to show that these two segments are congruent, we would have to know what about the picture?
That those triangles were congruent.
So she's got in the right direction. So let's kind of keep going. So now I've used this part of the given, the parallel, to prove step 2. And now I have
now we have 3 sets of congruent parts of those triangles. So, and if I look at them, I notice that it's an angle. It's the included side in the angle the way that we've done it. If you did it with the vertical angles, you would have angle side because you're going to be having a side that's not included between whichever two you have.
And let me just show you. If I had this labeled here, I would have then angle side or angle side, depending on how you label it. One other thing, and I noticed this the other day with some of my students, is that some people were saying these angles here were congruent, the vertical angles,
and they said
the third angle theorem.
Oh, see, and I didn't have anybody do that. I saw some people wanting to say that it was reflexive because they called it angle A is congruent to angle A.
Yeah.
And that's definitely not true. It's not the exact same angle. So really be careful with your naming when you see multiple vertices coming off. But yeah, let's talk about that third angle theorem.
And then what I was kind of stressing is that you could have said these angles right here are congruent because of third angle theorem because of the fact that you already had 2 sets congruent. Now, that's if you stated these 2 first.
Right, but we don't need the third.
No.
So really the third angle theorem, it is helpful to talk about other parts being congruent, but it's not necessary when we're proving triangles congruent first.
Okay.
So now that I've got 3 congruent statements, I know I do want to prove those 2 triangles congruent to be able to then talk about their parts. So just looking at that, I can say triangle MAS is congruent to triangle TAR. And I know I had to start because I started with M. I needed to start with T because they were corresponding parts. Because I ended with S, I want to end with the R because they're corresponding parts. A goes in the middle. And that reason would, for what I have, be side, angle, side. Sorry, angle, side, angle.
That's
oh
easy
my goodness.
to do.
Angle, side, angle. Now, as I look at that, if, again, I had done one of the vertical angles instead, I would have had angle, angle, side. Okay. So now, I know I want to prove that A is the midpoint of MT, which I can't go straight to saying that yet, but I know that if it is the midpoint, that would mean that it's dividing that segment into 2 congruent segments. So I think what I want to do is say that MA is congruent to segment AT, and that reason would be because all those corresponding parts are congruent, so CPCTC.
And notice again, you proved congruent triangles, you're using CPCTC again, okay?
And then from there I noticed that because the segments are congruent, that means that it is definitely the midpoint of that segment. So I think now I can go to say A is the midpoint of segment MT. And I don't want to use CPCTC again, but I'm just that's the definition of a midpoint.
And I like that you said that because I've had students in the past that want to use CPCTC and saying A is the midpoint. This is used to prove
something else congruent
stuff. Anytime you use like vocabulary in your statement, your reason's going to be a definition. All right, so keep that in mind. All right, so this one added a little bit of extra compared to the one we did the last one, but you're still again proving triangles are congruent using CPCTC, and then you might have a little bit extra involved.
All right, for this next one, we have that PM bisects an angle, and this is something that I've noticed some of my students struggle with a little bit. When we've got a segment bisecting an angle, what should it be forming, Mrs. Palermo?
Congruent angles.
Congruent angles. So when you're bisecting an angle, you're definitely forming congruent angles. So be careful with that.
Not congruent segments.
Yes.
So we have a segment bisecting an angle, which I'm already thinking, I'm looking at that picture and thinking about it. We also have a pair of congruent segments. So segment LM is congruent to segment NM. The other thing I'm noticing is that there are multiple triangles in this picture.
Yes.
And I also noticed we're trying to prove congruent triangles. And we've done that. We've proven congruent triangles. But you're going to notice this one's going to be a little bit different. And I like that she's kind of highlighting those are the two triangles we're trying to prove congruent. And one thing I noticed right away is the stuff I gave you, the congruent stuff that we were given, is not sides of those two triangles.
Right.
So what does that mean then? Like, they gave you stuff that's not useful?
It probably is useful, right? Or they wouldn't give it to you.
Exactly.
But maybe what's going to be helpful is to talk about something else, some other triangles in here being congruent first, because as I'm looking at this picture, what I'm hoping that you guys are seeing is that some of these triangles are overlapping.
Yeah.
To where they're going to have some corresponding parts that are congruent. So as I look at this picture, I can tell you that there's, in fact, what other triangle do you see that's overlapping with those two triangles?
Well, overlapping would mean they like kind of share
some stuff. Yeah.
So the two triangles that you have highlighted, the ones like right below it aren't really overlapping. They do share some stuff. So the two smaller ones, the two bottom ones.
These share what?
They share some sides.
They share common sides.
But
that's only one piece.
Yeah, that doesn't share a lot. So the one thing is you want to look for things that share a lot more because then you can do a lot more with it.
Right.
So the overlapping ones are like the triangle NMP. So this one there and then the one right next to it. So triangle PLM. Those two right there.
So these are the ones that I bet if I tried to prove that these two triangles were congruent, then I'm going to have a side that I could maybe talk about being congruent. I could talk about these angles maybe being congruent. So I think that's going to allow us to talk about more things within that triangle.
Okay.
Okay. Now, we have to first be able to prove these bigger triangles to be congruent.
Okay.
Right now, all we have is what?
A pair of sides.
A pair of sides. But they also told us one more thing that's going to help us out. What else?
The bisecting of an angle.
Yes. So let's talk about that for a minute. If PM, the segment that comes down the middle of our triangles, or kind of splits the two triangles, is bisecting angle LMN.
That means angle LM, either O or angle LMP, however you want to word it.
And it really won't matter, yeah.
So let's call it LMP is congruent to angle NMP. Now, again, this is just coming straight from the given. This is just stating, hey, we got something bisecting. Here's some congruent angles.
And that reason was
definition of angle bisector. Now, here's the deal, guys. It's not going to be always obvious about where you're going with this, but why? But so I want to restate the fact that they gave you something that's not directly in the two triangles that you're proving congruent. So the fact that they're giving LM is congruent to NM, those pieces are not part of the two triangles you're proving congruent. And, you know, Ms. Hograby kind of highlighted the two triangles that we're going to go. Sometimes that's not even obvious. Like a lot of times what I see in this problem is that people want to prove the two smaller ones at the bottom are congruent. And, I mean, there's a way you could go about doing that. Like I could see I'm almost there to it. But the fact that those two the lower two triangles don't have enough in common with the top two.
Yeah, if we did those two bottom triangles, we'd have a side in common. We could maybe then talk about the vertical angles, and we could then, but it's not really just using all the corresponding parts are congruent. It's going to take more steps. So we would encourage you to look for pieces, look for the most overlapping stuff that you can.
Things that they have in common. And if it helps to redraw even the picture, you know, just redraw the two larger triangles or redraw the two smaller ones. It just kind of is up to you what helps you. All right, so I'm looking and I'm still trying to, we decided if I could prove the two bigger ones that you have highlighted are congruent. I have a side and an angle And the fact that they share segment PM, I can go ahead and say that's congruent.
Absolutely. And that's what I think that some of you guys are getting really comfortable with now, looking for that reflexive side.
And that can be thrown anywhere before you prove the congruent triangles. So that's congruent, reflexive. Now I can say that those two larger triangles are congruent.
Okay.
So I can say triangle PNM is congruent to triangle PLM. And my reason is because a side angle, is it side?
I don't have it marked, but yes.
Okay.
So side, angle, side.
Good.
Okay, so are we done?
Well, we proved
proved
triangles are congruent, but we didn't prove the right ones.
Not the right ones.
So it's
Okay.
not like we're wrong, but here's what you got to think about. If I know that the congruent triangles, then I know corresponding parts are congruent, right?
Right. Now, looking at what we're trying to prove, the two triangles that we have up here in kind of orangey color, when you look at those, what parts of those triangles do we have because we now have the blue triangles marked as congruent? What parts do you see here that correspond? So now that we've proven these, let's try it. So now that we've proven these orange triangles to be congruent, we would need to look for what are those corresponding parts in these blue triangles that we could then put with them to be also marked. What parts are congruent?
Okay, so once we know congruent triangles, we know basically 3 more congruent pieces. And since they're not really telling you what pieces you need, but like you said, what parts do those larger triangles have in common with the 2 smaller ones? So I see that they share segment NP and segment PL. So I know those can be congruent. And I also see they share some angles, those top angles. So angle NPL or NPM, sorry, angle NPM is congruent to angle LPM. And that's because of CPCTC.
So we have several things that we could talk about being congruent. Those are going to be the ones that are most helpful because the angles that are not marked yet, really only part of it is in the triangles that we're trying to prove congruent. Okay, so now looking at these 2 triangles up here, and now is when it's going to really be helpful to take away, and I'm just going to look at just the smaller one. Here's what I've got marked on it. 1, 2, 3, 1, 2, 3. And I've got these angles up here were marked congruent too. What other piece of those 2 triangles do we know that's congruent?
Well, they share that in between sides. So segment PO is congruent to segment PO because of reflexive.
And is that enough?
And that's enough because there are 3 pieces. And so now I can say those 2 triangles, PNO is congruent to triangle PLO because of side angle side.
Sounds great. So notice, guys, again, we are still proving these congruent triangles to then use that information for something else. We just have to be careful with which triangles are they that we really need to work on to be able to talk about being congruent.
All right, one more question. And this one, it's got some angles labeled with numbers. That kind of helps with naming.
It does.
I like that a
I
little
do
bit better.
too. I wish they did that more often.
All right, so I'm going to go ahead and label the congruent angles that they're giving you. And notice, again, this one they are having you prove congruent triangles. And
but I see lots of triangles
and it might
up there.
help to kind of highlight those particular ones, the ones that you're dealing with. So triangle, what is it, BCE, this is the one we're trying to prove congruent to triangle DCE. And one thing to also notice, the given. Does the given give you information directly about that triangle?
Well, it gives us one thing about that triangle. But I noticed that I've got things that are not part of that triangle too.
Like these over there.
Those over there, the 3 and the 4. So, but I'm seeing again that overlapping triangle idea. And I'm seeing with the 2 angles that they give me, they're probably, or it may be helpful to me, to prove something about triangle CDA and triangle CBA. Because that's where I see I've already got 2 angles, and I think most of us can probably start to see that reflexive side that they're going to have in common too.
So again, if you need to, she's talking about those two larger ones. So the CDA and the CBA. And we already know these are congruent, right? And we already know these are congruent. So we already have two sets of congruent pieces. But that's to prove the larger triangles. But why did we choose those? Well, because those two triangles have stuff in common with the two we're trying to prove congruent.
Exactly.
All right. So
I'm going to say that like I said, of the larger triangles, CA is congruent to itself because of that reflexive property. And that right there is enough to allow me to talk about those two larger triangles being congruent. So triangle CDA is congruent to triangle CBA. And that reason is angle, side, angle. I noticed that it's that included side.
Okay.
All right. Now that I know that those two triangles are congruent, I'm really wanting to look at what's overlapping. I already have angle 1 and angle 2 marked. So I don't need to state that. But they also have a side in common. I noticed that CD and CB are part of the larger triangles. They're also part of the smaller triangles. So I can say that CD is congruent to CB. And that reason is CPCTC. Those corresponding parts of congruent triangles are congruent.
Again, notice she proved congruent triangles. She's proving their parts are congruent.
Yes. And I'm going to say, can we go ahead and draw just the smaller triangles separately?
I was about to do that.
Yeah.
Nice idea. She's thinking like me.
Great minds. Just looking at that, I noticed that we've got an angle and we've got a side. Oh, and we have a reflexive side. Sometimes it's easier to see them once you pull it apart just because we've got so many things marked on that picture. So I'm going to say CE is congruent to CE. And that's because, again, of that reflexive property.
And to restate that again, sometimes redrawing the picture is important. So if it's in, if it's on a classwork assignment where you can't draw on that paper, redrawing it. I know it takes a little bit extra time, but it's so much more helpful.
It really doesn't take that much time either.
I know, but...
I know. Okay. Now that I've got that, I'm looking at my picture, and if I mark that reflexive side congruent, then I definitely have enough to prove those two triangles because I have all three pieces. And so I'm going to say triangle BCE, that's how they told me to name it, is congruent to triangle DCE, and that is side, angle, side.